Alright, welcome everyone. Let's look at homework assignments for Chapter 2, Section 1. First question, determine whether the following statement is a statement. Remember, if it's a statement, it's either true or false. Then classify a statement as true or false. Why don't you come here? That's a question, so it's not a statement. Determine whether the following statement is a statement, then true or false. 5 minus 3 equals 2. Yeah, it's a statement, it's a declaration. So that's saying that 5, we'll take away 3, is 2. That is a true statement. You can prove whether it's true or false. Determine whether the following is a statement, then true or false. Can you bring me a book? Again, it's a question, it's not a statement. X plus y equals x minus y, where y equals 0. Again, if y is 0, then x equals x, then it's a true statement. Brazil is in Asia. Can you prove that? No. It is a statement because you can look it up and it's either true or false. Is it true? No, it's false. It's a false statement. Use a quantifier to make the following true or false, as indicated, where x is a natural number. X is natural. Make false. X minus 14 equals 14 minus x. There is no natural number x such that x minus 14 is... Okay, that one's true so far. Remember, natural numbers are our counting. We start counting 1, 2, 3, all the way into infinity. For x equals 14, 14 minus 14, okay, that could be, but again, you can't do that. X 14 minus 14, 14 minus 14. That makes it equal 0, and 0 is not in there, so it can't be B. At least one natural number exists, and it's not true because if you put any natural counting number in there, you get a positive and a negative number, so no. There's just, so no. The only one that's true that could work is there's no possible answer. Write the negation of the following. So the statement is 8 plus 2 is equal to 10. The negation of that is 8 plus 2 is not equal to 10. Just not equal to 10. State the inverse of the following. If you practice, then you will win. If you do not practice, then you will not win. That sounds like the inverse to me. The converse is if you flip them. The inverse is just negate the two statements. So if you do not practice, then you will not win. The converse would be if you win, you will win if you practice. If you win, then you practiced. State the contrapositive of the following. Remember, contrapositive is you flip them and negate them. So the negation of this one is it is not raining, then it is not pouring. Construct a truth table. I only have two possibilities? No. Yeah. Okay, let's look at this one. Well, let's see, let me get scratch papers. It's going to take us some space. So number 10. S so let's take this one. We have S RQs. We have 3 letters. We need 8 rows. So look at it. We have S, R, and Q. So we have 8 rows. So let's start with the innermost. So we have, it could be true, 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 false, false, true, or false, false. That's for S to being all true, because those are all different possibilities. Now how about when S is false? There has to be 4 possibilities of those. It could be true, 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 false, false, true, false, false. So when we read this, think of the order of operations. Okay, we have S already, so we can't do anything until we get that answer. So we have to do inside parentheses. We have R and Q. We first have to figure out R and Q. That's AND, because it points up. And AND is that single pipe. So true and true, they're both open. One's closed. One's closed. They're both closed. They're both open. One's closed. One's closed. They're both closed. So that's the parenthesis. Now we have to negate that statement. Negating R and Q means just change the signs. True becomes false. False becomes true. False becomes true. False becomes true. True becomes false. True, true. So now we have S and not R and Q. We have to do the OR statement. So the OR statement. And remember, that's that Y football goal thingy. If either one's open, then water's going to go through. So true or false, true. True or true, true or true, true or true, false or false, true or false, false or true meaning, and false or true. We have 1 false in there. Alright, so what's the question asking? So we're looking at the last column. It's got to be B, because this has too many F's. So it's got to be B. Okay. Construct a truth table for the following statement. Number 11. We have S and T, or not S and not T. Fortunately, we only have 2 letters, so we need 4 rows. So we only use letters S and T. could be true, 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 false, false, true, false, false. So first we have to do inside this parenthesis. So we have to do the S and T. Remember, the AND is that single pipe. So they both have to be open. True, open, open. Water comes out. Open, closed. No water. Closed, open. No water. They're both closed. No water. Now we have to do the second parenthesis. But before we do the second parenthesis, we have to find the negations of both S and T. So the negation of S. True becomes false, and false becomes true. Negation of T. T becomes F, F becomes T. It's like changing a number from positive to negative. That's all that negation does. So, we have the first parenthesis. Now we have to create the second parenthesis. S, not S, and not T. This is a single pipe, so both closed, no water. One's closed, no water. One's closed, no water. They're both open. So now we want to look at this and this column. That's what it says. We have to find the S and T, or not S and not T. We just look at these two columns. It's the OR statement, so that's that football goal. If either of them is open, it works. False, they're both closed. They're both closed. One's open. So it's TFFT. TFFT has to be number 11. Or B, I mean, yeah, it's got to be 11 because it's a question. Let R stand for the food is good, and P stand for I eat too much, and Q stand for I'll exercise. Write the following in symbolic form. If I eat too much, because it's an if-then, so we use I eat too much, that's P, then I'll exercise. If P, then Q. That's Q, then P, P, then Q, it's B. R is the food is good, P is I eat too much, Q is I'll exercise. If the food is good, that's R, then I eat too much. If R, then P. That's A. Okay, same thing. R is food is good, P is I'll eat too much, Q is I'll exercise. It's an if-then statement. Now, wherever the parenthesis, the comma is, that's where you separate. So this is all the if statement, and there's the then statement. So I'll exercise goes by itself, because it's after the comma. If the food is good, or I ate too much. So if the food is good, or I eat too much. We have to do that first before I go on. So R or P, then Q. That's D. I'll exercise if I eat too much. There's the word if. So if I eat too much, that's P, then I'll exercise. I'll exercise if I eat too much. So I'll eat if I eat too much, then I'll exercise. P, then Q. That's A. Determine the validity of the argument. Remember, to test the validity of the argument, you have to take all the premises however many you have, and then test the conclusion. So there's the word therefore, so that's the conclusion. Not all that glitters is gold. So P is all that glitters is gold. So not P is not all that glitters is gold. Q, my ring glitters, therefore my ring is gold. So we have to look at these two statements. Not P and Q. Does that lead to R? My ring is gold, so not R. My ring is not gold. So we have to test this argument. So it's a negation, so it's not P. And there's a second argument, my ring glitters, that's Q. Then my ring is not gold. So let's just look at this. So we have 3 letters, P, Q, R. So we have 8 rows. And the inner one, we do true, 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 false, false, true, false, false. That's for when this one's all true. We'll repeat it. True, 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 false, false, true, false, false. That's when the P is false. So to build this statement, we have to do inside the parentheses. So we have to find not P first. So just change all the T's to F and all the F to T's. So now we have not F. Now we have to do not P and Q. So look at these two. So not P and Q. That's the single pipe. If either one's closed, no water comes out. If they're both open, it comes out. Okay, so there's the first part. Then we have to find not R. Change these letters, so it's true becomes false, false becomes true. Now we have everything. We can create the statement, or the argument. If then, we're looking at this, and we're looking at that. So, if then is that valley, As long as you stay the same, it's okay. That says false or true, that's going up, that's good. False to false, that's good. False to true, that's good. True to false, that's bad. Stays the same as true, true. False, true. So we have one false in there, so it's invalid. In order to be valid, all of them have to be true. So it's not valid. Likewise, determine the validity of this. Alright, so we'll do the same thing. Let's create. Some TV shows are comedies. So what is some TV? Not all. All comedies are hits. Therefore, some TV shows are hits. So some TV shows are comedies. All comedies are hits. Therefore, some TV shows are hits. P and Q, then R. That's going to be too simple if we try to do it that way. It can't be. Alright, let's look at this. So it says some TV shows are comedies. Some TV shows are comedies. That's easier if we look at. Let's look at Venn diagrams here. So here, these are comedies. This is TV shows. So some of them are comedies. Some TV shows are comedies. Others aren't. Comedies are hits. These are all hits. So some TV shows are hits. Yes, it's valid. I'm sorry. With the conditional ones, it's difficult to create the truth table form. It's possible, but not the length we have here. So we can make Venn diagrams. Like I did here. It says some TV shows are comedies. You have TV shows and comedies. So some of them, they overlap. There's some TV shows that aren't comedies, and some comedies are not TV shows. They could be plays or books. And then all comedies are hits. So all of these are hits. Therefore, since there's some TV shows are comedies, that means some of them are hits. That's valid. Write a valid conclusion based on the statement. If I get robbed, I will go to court. I got robbed. So if then. If I got robbed, then I go to court. I got robbed, then I'll go to court. That was that first property, the first rule of Aristotle, remember? I'll show you what that is. Yes, the most. If I get robbed, I'll go to court. I got robbed, therefore I'll go to court. So it's because of modus ponens. It's true. I go to court. Write a valid conclusion based on the statements. Every man with a mind can think. So it's every. So let's think. So here's every man with a mind can think. A distractive man can't think, so it's disjoint. Distractive man. A man who is not distractive